Imagine walking through the grand streets of Babylon over 4,000 years ago. The city was a hub of culture, innovation and learning. Towering ziggurats, these massive step-like temples, dominated the skyline reaching towards the heavens. But these weren't just impressive architectural feats, they were the very heart of Babylonian spirituality and science. For the people of Babylon, the night sky wasn't just about beautiful sight. It was a canvas filled with stories, divine messages and cosmic patterns waiting to be understood. Astronomy wasn't just a hobby or a scientific endeavor, it was deeply ingrained into their culture, religion and daily life. Babylonian priests, who were also the astronomers of their time, would climb to the top of the ziggurats to observe the stars more closely. They believed that the movements of celestial bodies were messages from the gods. Each planet, star and constellation held significance, influencing everything from agriculture to decisions made by kings. The positions of Venus, Mars and other planets were thought to predict events like floods, famines and even the outcomes of wars. Their dedication to watching the skies led to some incredible achievements. They were among the first to create detailed star maps and calendars based on astronomical observations. The Babylonians divided the sky into recognizable constellations and even developed an early form of the Zodiac that we still reference today. Their ability to predict celestial events like eclipses was astounding for their time. But why was this so important to them? Well, life in ancient Mesopotamia was closely tied to the rhythms of nature. Knowing when the rivers would flood or when to plant and harvest crops was crucial. By observing the heavens, they sought guidance and understanding of the world around them. Astronomy helped them bring order to the chaos, offering a sense of control and connection to the divine. The Babylonians weren't just casual stargazers, they were pioneers, turning their eyes to the night sky with a purpose and passion that was truly groundbreaking. Imagine priests and scholars standing atop of towering ziggurats night after night, meticulously observing the stars and planets. They weren't simply admiring the beauty of the cosmos, they were systematically studying it, seeking patterns and meanings in the movements above. Their dedication led to one of their most remarkable achievements, the creation of detailed star catalogues. These were ancient celestial maps that recorded the positions and movements of heavenly bodies with surprising accuracy. One of the most famous of these is mul.apin tablets. Dating back to around 1000 BCE, these clay tablets are a treasure trove of astronomical knowledge. Inscribed with cuneiform script, they list stars and constellations, their rising and setting times, and even instructions for predicting celestial events. But the mul.apin tablets were just one part of their extensive work. The Babylonians also produced texts like Enuma, Anu, and Lil, a massive collection of omens and observations that linked astronomical phenomena to events on Earth. They believed that the gods communicated through the movements in the sky, so keeping detailed records was essential for interpreting these divine messages. What's truly amazing is how accurate their observations were. Without the aid of telescopes or modern technology, they charted the paths of the Moon, the Sun, and the 5 visible planets: Mercury, Venus, Mars, Jupiter, and Saturn. They noticed that while most stars held fixed positions relative to each other, these planets wandered across the sky. In fact, the word planet comes from a Greek word meaning wanderer, a concept that Babylonians were already familiar with. Their star catalogues weren't just scientific records, they were practical tools. The Babylonians used them to predict celestial events like eclipses, which had significant religious and cultural importance. They developed mathematical methods to calculate the timing of these events, demonstrating an impressive understanding of astronomical cycles. These observations also had everyday applications. By tracking the positions of certain stars and constellations, they could determine the best times for planting and harvesting crops. For example, the rising of the star Sirius might signal the flooding of the rivers, an essential piece of information for an agrarian society. Their calendars were intertwined with their astronomical observations, guiding not just agriculture, but religious festivals and civic activities. Beyond the mul.apin tablets, many other artifacts have been discovered that showcase their astronomical prowess. Clay tablets with intricate carvings and writings reveal tables of lunar and solar data, planetary positions, and even corrections to previous observations. This indicates a continuous effort to refine and improve their knowledge over generations. It's important to appreciate the context of their work. The Babylonians didn't separate astronomy from astrology or religion. It was all part of a unified effort to understand the universe and their place in it. The sky was a canvas painted by the gods, and by studying it, they sought to decipher divine will and maintain harmony between the heavens and the earth. Their systematic approach set the stage for future astronomers. The meticulous records kept by the Babylonians were later studied and built upon by Greek astronomers like Hipparchus and Ptolemy. The legacy of their star catalogues can be traced through history, influencing astronomical methods and knowledge well into the modern era. Think about the dedication it took to create these catalogues. Night after night, year after year, observing, recording, and analyzing, all without the conveniences we take for granted today. Their achievements remind us of the incredible human capacity for curiosity and the pursuit of knowledge. One of the most fascinating achievements of the Babylonian astronomers is the development of the Zodiac and their understanding of constellations. Imagine standing under the clear, star-studded skies of ancient Mesopotamia. Without the glow of modern city lights, the night sky would have been a breathtaking tapestry of twinkling stars and wandering planets. The Babylonians were among the first to systematically observe the heavens. They noticed that the sun, moon, and the planets moved along a specific path in the sky, which we now call the ecliptic. To make sense of these movements, they divided this path into 12 equal sections, each covering 30 degrees of the sky's 360-degree circle. Each section was assigned a constellation, forming what we now know as the Zodiac. These 12 constellations weren't just random groupings of stars, they were deeply embedded in Babylonian mythology and culture. They included familiar figures like Taurus, the bull, Leo, the lion, Scorpius, the scorpion, Aquarius, the water bearer, and Pisces, the fish. Each constellation held its own stories and significance, often linked to gods, heroes, and legendary creatures. By mapping the sky this way, the Babylonians created a celestial calendar that was incredibly valuable for their society. Agriculture was the lifeblood of Babylonian civilization. Knowing when to plant and harvest crops was crucial for feeding their people. The movements of the constellations provided a reliable guide for their activities. When Taurus rose in the night sky, it signaled the beginning of spring, a time to start planting. The appearance of Scorpius marked the onset of hot, dry season, indicating it was time to harvest. Aquarius, associated with the water bearer, brought the rainy season, guiding farmers on irrigation needs. By aligning their farming practices with celestial calendar, the Babylonians could predict seasonal changes and plan accordingly. This close observation of the stars ensured their agricultural activities were in harmony with the natural rhythms of the earth. The constellations also played a vital role in Babylonian religion and rituals. They believed that the stars were dwelling places of their gods, and that celestial events were messages from the divine. They developed an early form of astrology where the position of the sun, moon, and the planets within the zodiac constellations were thought to influence events on Earth and individual destinies. Important religious festivals were scheduled according to the celestial events. For example, the rising of certain stars might indicate it was time to honor a specific deity. Unusual occurrences like eclipses or the appearance of comets within a constellation were seen as significant omens. Priests and astrologers would interpret these signs to advise kings and guide decisions on matters like war, construction, and lawmaking. This deep connection between the cosmos and daily life meant that astronomy wasn't just about studying the stars. It was an integral part of their spirituality and governance. The zodiac served as a bridge between heaven and earth, allowing the Babylonians to feel connected to the divine and to seek guidance from the celestial realm. What's also remarkable is how the Babylonian zodiac has influenced cultures across the world. Their system was later adopted and adapted by the Greeks and Romans, and it eventually evolved into the zodiac signs many people are familiar with today. By transforming the sky into a cosmic map filled with a meaning and purpose, the Babylonians not only advanced the field of astronomy, but also enriched their cultural heritage. Their innovative approach allowed them to track time, predict seasons, and seek insights into both earthly and spiritual matters. In essence, the Babylonians turned the night sky into a cosmic calendar and a canvas for storytelling. Their legacy reminds us of humanity's enduring fascination with the stars and our timeless quest to find meaning in the universe around us. Building on their knowledge of stars and constellations, the Babylonians turned their attention to the wandering lights in the sky, the planets. To them, these weren't just points of light. They were celestial beings with significant influence over earthly matters. The Babylonians had a keen eye for observing the planets and a remarkable ability to predict their movements long before the invention of telescopes or modern instruments. They closely watched the 5 visible planets: Mercury, Venus, Mars, Jupiter, and Saturn. These planets fascinated the Babylonians because, unlike the fixed stars, they moved against the backdrop of the night sky in complex ways. They called them mul, meaning stars, but recognized that they behaved differently. Imagine trying to track Mercury, which is only visible for a short time during sunrise or sunset, or observing the steady glow of Venus, the bright morning star or evening star. The Babylonians meticulously recorded when and where these planets appeared, their brightness, and how they moved. Over generations, they gathered enough data to notice patterns in these movements. One of the significant achievements was identifying the synodic periods of the planets, the time it takes for a planet to return to the same position in the night sky relative to the sun as seen from Earth. For example, Venus has a synodic period of about 584 days, and Mars has a synodic period of approximately 780 days. By understanding these periods, the Babylonians could predict when a planet would reappear in the night sky, disappear, or reach its greatest brightness. This was incredibly useful for both practical purposes and astrological interpretations. But they didn't stop there. The Babylonians also developed methods to predict lunar eclipses which occur when the Earth comes between the Sun and the Moon, casting a shadow on the Moon. Through careful observations, they discovered the Saros cycle, a period of about 18 years and 11 days after which eclipses repeat themselves. This knowledge allowed them to predict not just when an eclipse would happen, but also where it might be visible. Predicting eclipses was a big deal. Eclipses were seen as powerful omens, often associated with significant events or changes. Being able to forecast them gave the Babylonians a sense of control over the unknown and allowed priests to prepare rituals or advise the rulers accordingly. Their predictions weren't based on superstition alone. They used mathematical calculations derived from their observations. They employed arithmetic methods to model the motions of Moon and the planets, which was a significant step toward understanding celestial mechanics. For instance, they used what's now called the System A and the System B models. System A involved a step function to predict planetary positions, and System B used zigzag functions to account for variations in speed. These mathematical models were surprisingly accurate for their time and demonstrated an advanced understanding of how celestial bodies moved. The Babylonians' ability to predict planetary positions also had practical implications. Certain planetary movements were linked to favorable or unfavorable conditions for planting and harvesting. Knowing the positions of planets helped the nighttime navigation both on land and the sea. Kings and leaders sought guidance based on planetary positions, affecting decisions on warfare, construction, and treaties. Their dedication to observing and predicting planetary movements showcased a blend of careful observations, mathematical innovation, and a desire to understand the forces that govern their world. What's truly inspiring is how they achieved all this without modern tools. They relied on persistent observation, recording data on clay tablets, and passing knowledge through generations. Their work laid the groundwork for future astronomers and mathematicians. The Babylonians' advancement in planetary observations and predictions highlight human curiosity at its finest. They didn't accept the movements in the sky as mere mysteries. They sought to understand and predict them. This quest for knowledge is a thread that connects us to them across the millennia. Their legacy reminds us that the desire to explore and make sense of the universe is a fundamental part of who we are. The Babylonians looked up at the same night sky that we see today, and through their ingenuity brought the heavens a little closer to Earth. Now let's explore one of the most impressive aspects of Babylonian astronomy, their use of mathematics to understand the heavens. It's truly remarkable how these ancient astronomers, without the tools we have today, developed complex techniques to calculate the movements of celestial bodies. Their work laid the groundwork for calendars we use even now. Imagine being a Babylonian scholar, sitting under the vast night sky filled with stars. You're determined to make sense of the patterns you see. Over time, you start noticing that celestial events repeat in cycles. The Babylonians were brilliant at spotting these patterns and turning them into mathematical formulas. One of their key achievements was creating methods to predict the positions of the moon and planets. They observed that the moon's motion wasn't constant. It sped up and slowed down at different points in its orbit. To model this, they used what's now called zigzag functions. Think of it like drawing a line that goes up and down in a zigzag pattern, which helped them account for the changes in speed. For the planets, they developed arithmetic sequences to predict where a planet would be in the sky at a given time. They used steps and intervals, adding or subtracting values based on their observations. This method allowed them to create tables that could forecast planetary positions years into the future. One of the most fascinating things they did was calculate the Saros cycle. This is a period of about 18 years, 11 days and 8 hours, after which lunar and solar eclipses repeat. By understanding this cycle, the Babylonians could predict eclipses with surprising accuracy. Imagine the awe and respect they must have commanded by foretelling such dramatic celestial events. But how did they use all this mathematical knowledge in everyday life? It all came down to their calendars. The Babylonians were deeply connected to the rhythms of nature, and having an accurate calendar was essential for agriculture, religious festivals, festivals and daily life. They combined their mathematical techniques with astronomical observations to develop both lunar and solar calendars. In the lunar calendar, the Babylonians noticed that the moon went through its phases, from new moon to full moon and back, in about 29.5 days. To keep track of this, they created months that were either 29 or 30 days long, aligning with the lunar cycle. A typical year would have 12 lunar months, totaling about 354 days. However, since this didn't match the solar year exactly, they added an extra month every few years, a process called intercalation, to keep their calendars in sync with the seasons. In solar calendar, they knew that the solar year, the time it takes for the Earth to orbit around the Sun, is about 365.25 days. Using their mathematical calculations, they accounted for this extra quarter of a day by adding an extra day every 4 years, much like we do with leap years. This helped them predict the changing of seasons accurately, which was crucial for farming activities like planting and harvesting. By combining the lunar and solar observations, they created a lunisolar calendar, balancing both cycles. This was no small feat. Their calendars were so precise that they could predict not just the seasons, but also the exact dates of important festivals and events. The Babylonians didn't have calculators or computers, yet they managed to perform complex mathematical operations using simple tools like clay tablets and styluses. They wrote down numbers using sexagesimal system, which is why we have 60 minutes in an hour and 360 degrees in a circle today, a lasting legacy of their mathematical brilliance. Their work wasn't just theoretical, it had practical applications that impacted their society every day. Farmers depended on calendars to know when to sow and reap. Priests used them to schedule religious ceremonies at precise times. Kings and rulers planned events and made decisions based on celestial predictions. Picture a Babylonian astronomer sharing his predictions with townspeople. In 3 months' time, there will be a lunar eclipse. When that day arrives and the moon darkens just as he said it would, imagine the sense of wonder and respect it inspired. Their ability to harness mathematics to decode the sky speaks volumes about human ingenuity. They turned observations into numbers, numbers into predictions, and predictions into a system that guided their entire civilization. The Babylonians' mathematical astronomy was a monumental achievement. They laid the foundations for the calendars we still use, and their methods influenced future generations of astronomers and mathematicians. It's a testament to their curiosity and dedication, and even thousands of years later, we are still captivated by their accomplishments. The brilliance of Babylonian astronomy didn't just stay within their own land. It spread far and wide, influencing civilizations that came after them, especially the Greeks and the Islamic world. The Greeks were fascinated by the sky just like the Babylonians, and they benefited immensely from Babylonian knowledge. The Greeks adopted the Babylonian Zodiac system, dividing the sky into 12 sections, each with its own constellation. This became a cornerstone of Greek astronomy and astrology. Babylonian mathematical methods, especially their way of calculating planetary movements, influenced Greek astronomers. The Babylonians used a sexagesimal number system, which the Greeks found incredibly useful for astronomical calculations. That's why we still have 360 degrees in a circle today. Greek scholars like Hipparchus and Ptolemy build upon Babylonian observations. Hipparchus is known to have used Babylonian star catalogs to create his own, improving the accuracy of star positions. Ptolemy's famous work, the Almagest, drew heavily from the Babylonian data and methods. By integrating Babylonian insights into their own studies, the Greeks helped preserve and expand this knowledge, ensuring it wasn't lost over time. Centuries later, during the Islamic Golden Age, scholars in the Middle East became the new torchbearers of astronomical knowledge, and they too were greatly influenced by the Babylonians. In places like Baghdad's House of Wisdom, scholars gathered texts from all over, translating them into Arabic. Many Babylonian astronomical texts were among these works, preserved and studied with great enthusiasm. Islamic astronomers like Al-Khwarizmi and Al-Battani build upon Babylonian Greek foundations. Al-Khwarizmi's name gives us the word algorithm, and he was instrumental in developing algebra. Al-Battani refined the calculations of the solar year and improved the accuracy of astronomical tables. Inspired by earlier works, Islamic scholars established observatories to observe the sky more precisely. They compiled comprehensive star catalogs, echoing the Babylonian tradition of meticulous observation. The Islamic world became a crucial link in preserving and enhancing astronomical knowledge, which later found its way to Europe, spurring developments during the Renaissance. The survival level of Babylonian astronomical knowledge is nothing short of a miracle. The Babylonians recorded their observations on clay tablets using cuneiform script. These durable tablets survived millennia buried in desert sands. In the 19th and 20th century, archaeologists unearthed these tablets. Scholars worked tirelessly to decipher them, revealing a treasure trove of ancient knowledge. Through translations into Greek, Arabic, and eventually Latin, Babylonian astronomical texts reached a wider audience. This allowed their methods and discoveries to influence astronomers across different cultures and eras. The ripple effect of Babylonian astronomy are still felt today. Our 60-minute hours and 60-second minutes are based on the Babylonian-based 60 system. The division of circles into 360 degrees also comes from the Babylonian mathematics, aid in navigation, engineering, and astronomy. Many concepts in astrology trace back to Babylonian practices, showcasing their lasting cultural impact. The journey of Babylonian astronomical knowledge highlights something beautiful about human history: the sharing and building upon each other's discoveries. Each civilization didn't start from scratch, they learned from who came before them. The Babylonians provided a foundation for the Greeks, who passed the torch to Islamic scholars, who then influenced Renaissance Europe. This chain of knowledge reflects our shared curiosity about the universe. Despite differences in language, culture, and geography, the desire to understand the stars unites us. The Babylonians were pioneers, but their true legacy lies in how their insights sparked further discoveries around the world. Think about it, without their initial observations and mathematical techniques, our understanding of the cosmos might be very different today. They didn't just keep their knowledge to themselves. It traveled across borders and through time, influencing countless minds. Their story reminds us that knowledge is a living thing, nurtured by many hands and minds over generations. It's a testament to the power of human connection and the wonders we can achieve when we learn from one another. So, next time you look up at the night sky, remember the ancient Babylonian stargazers. Their eyes were among the first to systematically map the heavens, and their legacy continues to shine in every star we see. Thank you for staying with us right till the end. This is the episode 1 of the series Stargazers. I have 9 more prepared. They will be released every Wednesday going forward. If you enjoyed this video, please leave a like and subscribe to support our channel. Keep looking up.